All right, so in this video, I'm going to go through basically the theory from 7A, B, and C, including worded problems. The whole point of doing algebra is we want to solve real-life problems. This one we've got here, you don't need to copy it down, but we're going to work through it together. Emily's age in 10 years' time will be triple her current age. Now, what we're going to say is that Emily's age, why is this, I don't know, this wireless thing is like packing itself. Let me just see if I can... So what I'd like you to think about is, first of all, write an equation involving E to describe Emily's age. Okay? So first of all, Emily's age now, we'll call that E. All right, E. Okay. I think I need to be closer to the screen because it's, for some reason, it wasn't working. All right, so what we're going to say is write an equation involving E. I'm going to pause the video now, and I'm going to then restart it when you guys have had a chance to do it. Okay, so Bill has just said to me that so first of all, we're going to define what the variable is. The variable E is what? It's Emily's. Is it Emily's age in 10 years? Emily's age now. Okay, because we need to know what it is. Emily's age now. So what we're going to say is that Emily's age in 10 years will be triple her current age. So if we add 10 to Emily's age, now what type of, or what unit is it? We need to do a bracket and say what is it? This is in what? Is her age in bananas? Is her age in apples? What is it? In years. Okay? That's really important when we define a variable. Now, what we need to do now is that E plus 10, is this an equation? No, it's not. Why? Because it doesn't have an equal sign. E plus 10 is equal to triple her current age, is equal to 3E. Now, it says here, find a solution to this equation. Now, in the past, you've been guessing and checking, but I'm going to show you the algebra. What do I have to do? I've basically got two expressions on both sides which include E. Which one is the greatest out of this side and this side? Which one's greater? The one on the right, 3E. So what we do is we leave that there, and what do we do to both sides, Swapnil? I'm just going to come around to you. Hopefully that I don't lose the wireless. What do we do, Swapnil?
We take away E from both sides.
Beautiful. We take away E from both sides. So what I'm going to do is we're going to show our working. So the next, you could do it a number of ways, but what I'm going to do is I'm going to go subtract E from this side, and I'm going to subtract E from this side. What we're doing is we're using BODMAS. We're basically working our way up and down BODMAS to get rid of, when we're solving equations, when we're evaluating, we're going down in this direction. But when we're solving equations, we're actually going up in this direction. So we've subtracted E from both sides. What that means is that this E minus E is going to cancel out, and 3E take E is 2E. 2E is equal to 10. Now, we've taken care of the addition and subtraction. I've got 2E equals 10. Can I just ask over here, Alex, what operation at the moment is happening to E? What's happening to E at the moment? It's being
multiply.
It's being multiplied. What's the opposite of multiply?
Division.
It's division. You can see there, division and multiply. We have to use the inverse operation of multiply. So what we now need to do is need to divide both sides by 2. Show you working. So therefore, E is equal to 10 divided by 2 is 5. Find a solution to this equation. How old is Emily now?
15.
She's 5 now.
Emily's age is 5 now, thank you. How many years will she have to wait until she is 4 times her current age?
15.
What's that? She'll have to wait 15 years, thank you, because 4 times 5 is 20. So it's therefore, now that's one of the harder questions in 7A. Are we okay with that sort of thing?
Yep.
All right, good. Are you happy for me to move on? Okay, can I get you guys to try and do A, C and E from question 7B, which is up here on the board. I'm going to pause the video. We go, we're back in the room. All right, now, for this one. What you should have got is you've realised that we're using inverse operations. We're using the inverse of BODMAS. We're working our way up. First of all, you can see that x is multiplied by, Ethan?
3.
X is multiplied by, Ethan?
10, that's what I meant.
Thank you.
Yeah, sorry.
So what do we have to do? What is the inverse of multiplying by 10, Trent?
Dividing.
Dividing by?
10.
10, thank you. All right, so therefore the first thing is 10x divided by 10 is x. X is equal to 30 divided by 10 is, shout it out, 3. All right, Zach, you can see here that 4x plus 2 is equal to 22. How do I get rid of that plus 2? How do I get rid of that plus 2?
Minus 2.
By minus 2, thank you. So, you can see there that by subtracting 2 from both sides, we've suddenly get rid of this 4x plus 2. So 4x is equal to 22 minus 2? 20. Awesome. We divide both sides by 4, we get? What's the left-hand side? What's the left-hand side, Ben?
X.
Thank you. Dividing 4x by x. 4x by 4 is x. X is equal to 20 divided by 4, Tim. Thank you. Shh. All right, this last one, a little bit different. What we've done is they've actually left the 4x by itself, but I've subtracted 20 from both sides. What you need to realise, though, is you need to think about the number line. If I've got 8 over here, and I've got 0 over here, if I subtract 20, if I say 8 subtract 20, what is the result of that, Bill?
Negative 12.
Thank you, it's negative 12. Now what you can do is you can say that I'm subtracting 8, okay? And then, if you like, I'm subtracting 12. Can you see that 8 take away 8? Shh. Excuse me. 8 subtract away 8 is 0. You can always go back to 0 and then negative 12. Now, if we look over here, that's what they've done. However, what we've got to deal with, though, is we've got negative 4x. We've got negative 4x, and for some reason, this thing, we've got negative 4x is equal to negative 12. Now, we can divide both sides by what's happening to x at the moment. It's being multiplied by what, Zach? It's been x at the moment, where I've circled it in red.
So multiplied by 4.
Is it 4? It's multiplied by?
Minus 4. Sorry.
Minus 4. So what do we have to do to both sides? Divide by minus 4. Now, anything divided by itself is, if I have minus 4x divided by minus 4, what does that equal? X, thank you. Anything divided by itself, if you like, is going to be 1, whether it's negative or positive. You also need to realise that a negative times a negative, or a positive times a positive, is what? Positive. Same, positive. Negative times a negative, or negative times a positive is a? Negative. Now, x is equal to what? 3. Thank you. All right. Now, I'm going to pause the video again. Go. Oh, actually. Ready, set, go. All right. So this student has taken an equation 5 and he's performed some operations to it. He's multiplied it by 4. He's added 3 and he's times it by 2. Now, if you think about it, it says solve 4x plus 3 all times 2 equals 46 algebraically. What's the answer? What is the answer? Yes?
X equals 5.
Thank you. X equals 5. Because what we've done is we've done all of these operations. So, therefore, we've started at x equals 5. Now, describe how steps you use in your solution compared with the steps the student used. Now, what do we have to do? We're going to start with 46. We're working our way up. What's the opposite of times by 2? Divided by 2. Awesome. So, divided by 2, that gives me 23. We've covered that off. What's the opposite of plus 3? Subtract 3. 23 subtract 3 is equal to 20. What's the opposite of times 4? Divided by 4. 20 divided by 4 is equal to 5. There you go. Give it another example of equation that x equals 5 has a solution. Don't worry about that. But the whole point of this, ladies and gentlemen, actually we've only got gentlemen in here now, is using the inverse operation. Now, this question, I'm going to do this with you. Now, this is from 7C, I believe, and it's a worded question. Shh. Stay here until the video is finished, so no one speak over me. All right. A restaurant bill of $100 is to be paid. Blake puts 1/3 of the amount in his wallet, leaving $60 to be paid by the other people on the table. Write an equation to describe the situation. I'm going to pause the video very quickly and you're going to have a go at this now, please. Here we go. We're back in the room. All right. So what we've got is for this one, this is a tricky one. We've got $100 to be paid. But what has he done? He's put 1/3 of the amount in his wallet. So what we're going to say the amount of the bill is what? B? And we're going to say $100 minus B over 3 is equal to what? 60. We've now set up an equation, and that's going to be in dollars. Let's do it. 100 minus B on 3 is equal to 60. How do we solve that algebraically? What would I do first? All right. No, we can't divide times by 3. The only way we can do that is with a fraction. We're still going. The video's still going and I'm not letting any of you out yet. So let's get this finished. What we need to do is I'm going to do this. I'm going to subtract 100 from both sides. So I've got minus B over 3 is equal to 60 minus 100 is negative 40. What am I going to do to both sides now? I'm going to times by what? Times by negative 3. Times by negative 3. What that's going to do is it's going to cancel this out, and therefore B is equal to $120. Solve the equation and hence state how much money Blake has in his wallet. How much does he have in his wallet? Thank you. All right. I'm going to stop the video now. I'm going to post it on YouTube, send it